Imagine looking up tonight, and the moon is gone. That's when everything starts breaking. Planet-wide floods, pitch-black nights, ice ages stronger than anything Earth has ever experienced, strange skies glowing unfamiliar colors. This is what would happen if Earth lost its moon, and replaced it with other moons from across the solar system. And no, you wouldn't survive most of them. Let's start with one of the largest and strangest moons of all, Titan. You're used to our moon. Small, gray, quiet. But imagine looking up and seeing something enormous dominating the sky. Our moon is a familiar, comforting presence in the night sky. A silent silver companion on our journey through the cosmos. But what if, one night, you looked up and saw something else entirely? Something enormous, alien, and unsettlingly close, dominating the sky from horizon to horizon. Let's replace our moon with Titan, Saturn's largest and most mysterious satellite. This isn't just a slightly bigger moon, it's a world in its own right. With a diameter of over 5,100 kilometers, Titan is so large it dwarfs the planet Mercury. It's the only moon in our solar system with a substantial atmosphere. A thick, soupy orange haze of nitrogen and methane, far denser than Earth's. Beneath this smog lies a landscape that is both bizarrely alien and hauntingly familiar. The temperature plunges to a brutal -180 degrees Celsius, cold enough to freeze carbon dioxide solid. Here, the bedrock isn't rock, it's water ice, as hard as granite. And flowing across this frozen surface are not rivers of water, but rivers of liquid methane and ethane, carving channels and pooling into vast, placid seas. It's a chilling, primordial world, a glimpse into what a planetary body might look like in the frigid outer reaches of a solar system. If Titan were to take the moon's place, the change to our night sky would be immediate and profound. Our familiar silver moonlight would vanish, replaced by a perpetual dusky orange glow. Titan's thick atmosphere would scatter sunlight, bathing our nights in an eerie, hazy twilight, as if the world were lit by a cosmic sodium lamp. Stars would struggle to pierce the orange veil. Because Titan is nearly twice the diameter of our moon, it would appear immense, a fuzzy, indistinct giant hanging in the sky, its surface details obscured by its dense atmospheric shroud. It would feel less like a moon and more like a neighboring planet, uncomfortably close. But the visual spectacle would be the least of our worries. The delicate gravitational dance that keeps our planet stable would be thrown into chaos. Our moon's gravity locks Earth's axial tilt at a steady 23.5 degrees, giving us predictable seasons. Titan is 85% more massive than our moon. While it would exert a stronger pull, its orbital characteristics would fail to provide the same stabilizing resonance. Over millennia, Earth's axis would begin to wobble erratically. Our seasons would become unrecognizable. A city might experience Arctic winters followed by scorching, desert-like summers. Agriculture would collapse. The climate patterns that have allowed life to flourish for eons would be completely destroyed. The most immediate and devastating impact, however, would be on our oceans. Titan's immense gravity would pull on Earth's water with terrifying force. Tides would no longer be the gentle, predictable cycles we know. They would become monstrous, twice-daily tsunamis. Coastal cities like New York, Tokyo, and Amsterdam wouldn't just flood, they would be scoured from the map. Sea walls would be obliterated, entire regions would be submerged and then exposed in a relentless, destructive rhythm. The sheer friction of these super tides dragging across the ocean floor would generate immense heat, warming the oceans and further destabilizing the climate. It would also act as a brake on Earth's rotation, gradually slowing our planet down and lengthening our days. And this new arrangement would be a death sentence for Titan as well. Moved from the cold depths of the outer solar system to Earth's cozy orbit, it would be subjected to far more intense solar radiation. Its surface temperature would skyrocket. The liquid methane and ethane that form its rivers and seas would boil away, thickening its atmosphere into an impenetrable toxic smog. The water ice crust, once as hard as rock, would soften and melt. For a brief, tantalizing moment, Titan's long hypothesized subsurface ocean of liquid water might be exposed to the sky. But this watery paradise would be short-lived. Titan's gravity, while strong enough to wreak havoc on Earth, is too weak to hold onto its own atmosphere and newfound water in the face of the relentless solar wind. Over millions of years, it would be stripped bare, its precious volatiles bleeding into space, leaving behind a dry, barren, and lifeless husk, a ghost of the vibrant world it once was. If Titan's arrival was a shock, our next visitor would redefine our entire cosmic perspective. Imagine something not just bigger, but a true giant of the solar system, a moon so vast it dwarfs the planet Mercury. This is Ganymede. Discovered by Galileo Galilei in 1610, it is, without question, the largest moon in our solar system. If it orbited the Sun instead of Jupiter, it would easily be classified as a planet. Now imagine it replacing our moon. Our nights would transform into a perpetual, eerie twilight. Ganymede is not only 50% larger in diameter than our moon, but its icy surface is over 3 times more reflective. It would blaze in the sky with an almost blinding intensity, casting sharp, defined shadows and washing out all but the brightest stars. The very concept of darkness would become a rarity, a forgotten luxury. Astronomers would find their work nearly impossible, and the rhythm of nocturnal life across the planet would be thrown into chaos. But the light, however disruptive, would be the least of our worries. The real danger lies in its immense gravity. Ganymede is more than twice as massive as our moon, and its gravitational pull on Earth would be catastrophic. The gentle ebb and flow of our tides would be replaced by terrifying megatides, walls of water hundreds of feet high, scouring coastlines and surging deep into the continents. This immense tidal flexing wouldn't just affect the oceans, it would knead the Earth's crust itself, triggering constant violent earthquakes and awakening dormant volcanoes across the globe. Coastal cities would be rendered uninhabitable, and much of the world's population would be forced into a desperate migration inland. Yet, amid this planetary chaos, a strange and paradoxical stability would emerge. Ganymede's powerful gravity would lock Earth's axial tilt into a fixed position, ending the Milankovitch cycles that drive our ice ages. The planet would settle into a new, permanent climate state, devoid of glacial periods. But this stability would come at a terrible cost. Earth's tidal forces would, in turn, inflict their own transformation upon Ganymede. The constant gravitational stress would generate immense heat within the giant moon. Its thick, frozen crust, estimated to be over 100 kilometers deep, would begin to soften, crack, and melt. Over millennia, a new ocean would form on its surface. This would expose the colossal saltwater ocean already thought to exist beneath its ice, a hidden sea containing more water than all of Earth's oceans combined. If humanity could somehow survive the initial cataclysm, the once frozen moon in our sky could become a second water world, a new frontier born from destruction. But what if we swapped our serene moon for a world of chaos? Then comes Io, a moon of fire. At first glance, it's a mesmerizing jewel painted in shades of yellow, red, and orange. But this beauty is born from violence. Io is trapped in a gravitational tug-of-war, constantly squeezed and stretched by the immense pull of Jupiter and its neighboring moons. This relentless flexing generates incredible internal heat, turning Io's interior into a molten furnace. The result is a world that makes Earth's volcanoes look like tiny sparks. Io is the most volcanically active body in the entire solar system, boasting over 400 active volcanoes. Its surface is a constantly changing hellscape of vast lava flows and lakes of molten sulfur. Enormous plumes of sulfur dioxide erupt from its surface, blasting hundreds of kilometers into space. If Io replaced our moon, the night sky would transform into a terrifyingly beautiful spectacle. It would hang there glowing in eerie orange and gold, a constant fiery eye in the darkness. We wouldn't need telescopes to witness its fury. Major eruptions would be visible from our backyards as bright, flaring points of light. The constant volcanic outgassing would also rain sulfur compounds into our upper atmosphere, potentially creating spectacular planet-wide auroras, but also threatening the ozone layer over time. Surprisingly, despite its apocalyptic appearance, Io wouldn't immediately destroy us. It's very similar in size and mass to our own moon, so its direct tidal and gravitational effects would be familiar. The true engine of its volcanism is Jupiter. Without the gas giant's immense gravitational influence, the tidal heating would cease. Over thousands of years, Io's internal furnace would cool. The eruptions would slow, then stop, and its vibrant colors would fade. Eventually, it would become just another cold, silent, and pockmarked world, a ghost of the inferno it once was. Next is Europa, a moon wrapped in ice, hiding a vast ocean beneath its surface. Scientists believe Europa's underground ocean could be deep enough to support life. If Europa replaced our moon, nights would be brighter and colder. Tides would weaken. Over time, Earth's tilt would become unstable. But Europa would be close enough to visit in days. Humanity could walk its surface, drill through the ice, and search for life beyond Earth. Then there's Triton, a moon that orbits backward. If Triton replaced our moon, tides would weaken dramatically, and Earth's climate would become unpredictable. But the sky would be spectacular. Triton has ice volcanoes blasting frozen nitrogen into space. Over time, its frozen surface would vaporize, forming a hazy atmosphere before slowly fading away. Now imagine replacing the moon with something tiny, Phobos and Deimos. Mars moons are barely moons at all. If one replaced our moon, nights would become pitch black. Moonlight would disappear. Tides would collapse. Marine ecosystems would fail. Earth's tilt would wobble wildly, triggering ice ages, droughts, and mass extinctions. And eventually, Phobos would fall, straight into Earth, an impact larger than the one that wiped out the dinosaurs. Finally, Enceladus, a bright frozen moon spraying water into space. Beautiful, but too small. Replacing our moon with Enceladus would weaken tides, destabilize Earth's climate, and slowly push the planet toward chaos. Swapping Earth's moon sounds like a science experiment, but it's a reminder. Our moon isn't decoration. It stabilizes Earth, protects our climate, shapes life itself. Too big, and Earth breaks. Too small, and Earth falls apart. The moon we have isn't perfect. It's necessary.